everyone, I am Mrs. Padmashri from SNS College of Technology. Today I am going to explain the concept backpropagation algorithm in machine learning. So already in my previous video I had explained about what is backpropagation network. So do watch that video completely, then you can able to understand what is this backpropagation algorithm here. So let's move on to the algorithm directly. So the backpropagation algorithm, there are some few steps. Before I start with a few steps, I'll just give you the recap of what is a backpropagation network. So it is a multi-layered feed-forward network where the errors are mitigated, corrected, and backpropagate the error, then adjust the weights and bias. Then again the process starts feed forward the values to the output layer, compare the actual and the predicted. If there is no difference, no huge difference, then our output is correct. If there is any error, again we are going to backpropagate and repeat the steps till we get the actual output is equal to the predicted output is equal to the actual output. So this is what the concept of backpropagation algorithm simply. Okay, so the steps here, as I already told you, this initialization of weights will be the first step. Step 1, initialize the weight, which should be to a small random value 0, and while the condition is false, we need to repeat the step as I said 3 to 10 for each training pair, 4 to 9. Feed forward of inputs is the second step, and each input is termed as xi. Okay, his input is received and forwarded to the higher layer, next layer, hidden layer. So how we have to write the equation for that? Zing, which is the next layered input, is equal to Woj plus summation of xi into Wij. This is, as I said, each node is associated with its own weight. So summation of xi into Wij is nothing but input into weight plus Woj is bias. This is one equation, like we can say it's a neural network or any artificial neural network equation is bias plus the summation of input into weight, which is going to be the output of one layer, Zing. So this layer output, we are going to take it as an input to the next layer. So what we have to do the next layer, we need to check for the activation function. What is the activation function means? You are going to check whether the particular layer is active or not. So remember, whenever the node is particular node is active or not, whenever the node is active only, it can able to transmit the data to the next layer. If it is not active, we cannot transmit the data to the next layer. So every time after you complete bias plus input into weight, summation of input into weight, that value has to be, before you transmit to the next layer, check for the activation function, which is applicable for all hidden layer. One you will be checking, again send to second layer, again you will be checking for activation function. Fine. If you understand this concept, then this will understanding these equations will be very easy. So Zj is equal to the function. So we are going to check the output of this. So what is this Zing? Is the first layer's output. So we are going to apply the activation function, checks whether the node is active or not. That value is passed to the next layer. So next layer I am taking it as Yink, same bias plus summation of input into its weight. Vjk is the second layer's weight. So again you are going to apply the activation function for that second layer. Yk is equal to function of this Yink, checking this particular node is active or not. So again, so these two hidden layers we crossed. So the output, it goes to the output layer. So in output, del k is there is a change in the value. We always say whether there is a del or whatever it may be, we say it is there is a change in the error. So what is this? Tk minus yk into function of ink. This is activation function of this second layer, hidden layer 2's output, right? And what is this? Tk is targeted output minus yk. So this step 7 and 8, I'll go forward to my next slide. I'll explain there what is the step 7. del k, see the error, there is any change in the error, I said we mention it as del, the error of the kth output neurons, and tk is the targeted value minus yk is the actual value. So when you minus it, target value from the actual output, we will come to know what is the error value. So that based on the error we can able to adjust the weight of the input nodes. So that manipulating, it's all manipulating. So according to the output we are going to manipulate the input, then again we are feed forwarding, and so that we adjust the actual value should be equal to the target value. Okay, simple. So y of I and k, this is the derivation, the active function of the neurons y, I and k. This is the 7th step. 8th step again I will explain, del I and j. So here what is the 8th step? Del I and j equal to summation of del j into vjk. So the error of, so whatever del I we represent, it is the error of jth neuron, and del j error term for the jth output neuron, which is the INJ is the previous neuron, this is the output neuron, and always VJK the weight between the jth neuron in the previous layer. Okay, again I will go back to the same step. So this is the 2 step I had explained you now. Okay, then what I said, after we get some error, now what we need to do, update the values, weights and bias. So this is the corrected weight. Del is the change in the weight is equal to alpha into del k into z. So corrected weight, and the bias correction also, del woj is bias, wij is called a weight, that you need to remember. Wherever ij it is a bias, oj it is a, wherever ij it is a weight correction, and wherever oj it is a bias, is equal to del alpha into, alpha is a change, okay, change in the weight, and here change in the bias, into del k. Okay, so how to write the updated weight value? So you need to calculate the new weight. So whenever the new weight will be calculated based on the old weight plus the adjusted weight. So new weight is calculated, this is weight ij na, so it is a weight. When I say oj, it will be a bias. So new weight is equal to old weight plus the change in the weight. Same vjk, this is for the second layer, second hidden layer. So vjk of new is equal to vjk old values plus del change in the value, change in that particular network, particular layers value. So new bias is calculated, woj equal to old bias plus change in the bias, vok second layer old bias value plus change in the bias. So stop the condition, then again what we need to do, this already we had explained, step 7 and 8. This step will be continued to the till the output layer, and checks for the whether the predicted output is equal to the actual output. If there is equal, then no need to back propagate it, stop the algorithm. If there is the change in the error, then again we need to back propagate it. So this is the exact working of the neural back propagation network. So the merits, directly we'll go to the, what is the merit? It has yeah, merits are always there, right? It has a weight correction, right? Weight correction, and also it finds the error, and we are going to correct the error, and this computation time is less if weights are small. So that's why in the first step we are adjusting to the smallest, weights are adjusted to smallest random, we are keeping a smallest random value. So it is 100 times faster than the perceptron model. Systematic weight updation procedure is there. These are all the merits, and the demerits, it requires intensive calculations. As you all watch this video, like there may be some equations, so it is the calculations are a little bit difficult, and hidden layer are the issues, and because number of hidden layer that we need to carefully select how many hidden. Here in the network architecture I had shown only 2 hidden layer. Say for example, if there is 4, 5, 6, 7, then the architecture will be more hectic, right, to calculate the values. So that is the only drawback. Okay, training time is more because of more number of hidden layers, and it is a it's more for complex problem. Only for complex problem it takes more time. These are all the merits and demerits. And thank you for watching my video. Keep support my video. Thank you.